Hello, my dear students. Welcome to the new lecture. This lecture is based on pulse amplitude modulation, which is a very crucial part of digital communication. According to digital communication, we know that the purpose of the modulator is to convert discrete amplitude serial symbols, that means the bits and binary numbers, so 0, 1, 0, 0, this kind of bits and binary systems. AK, you can just code is as AK subset to analog output pulses which is sent over the channel. The demodulator reverses this process. So there is a modulator which gets the serial data symbols, and the analog channel pulses will go through to this channel, and after that the demodulator demodulates, it decodes all the signals, and they recover the data symbols. So that's the basic purpose of digital communication and basic propagation of data through modulator to demodulator for digital communication. Now, if we go further, we will find there is a possible approaches that are include while we transmit the digital data from modulator to demodulator. That is the pulse width modulation (PWM), pulse position modulation (PPM), and pulse amplitude modulation. So in this lecture, we will consider PAM, pulse amplitude modulation, to know further about the digital communication process. That can be abbreviated as PAM. So PAM is generally signaling technique whereby pulse amplitude is used to convey the message. Okay. So you can see here that is the PAM, and the PAM is general signaling technique whereby pulse amplitude. So amplitude is the main thing that has been changed as far as the uh, pulse goes. That is pulse amplitude, or pulse, you can say, width, and pulse position. So there are three things that can be changed. So in PAM pulses, that could be sampled amplitude values of an analog signal. That means there is an analog signal. So if you just get the sample out of it, so that's one kind of pulse amplitude modulation process. That means analog to digital conversion process. So we are interested in digital PAM, where the pulse amplitude are constrained to chosen from a specific alphabet at the transmitter. So that's the thing. That means we have to choose alphabet by decoding the pulse amplitude. Okay. So let's go to the next part. That's the PM. What is the PM scheme might be. So as we know, in the PM scheme, it depends on the amplitude. So there may be a modulator, there may be a demodulator, and a channel. It's a very basic type of system, a block diagram that we can see here. So here you can see there is a pulse generator which gets the symbol clock, and the symbols that can be converted as binary numbers, that's AK, and there's the sampling method, as you know from the sampling theorem. So the summation of the delta t minus k, that means the unit impulse functions are there, and the transmit filter is for just filter the pulses and give it a boost and make it a good signal to transmit. Then you can see here just the delta function has been substituted or yielded by the HT with the filter function. Then it will go through to the channel. So the channel is somewhat, you can transmit the frequency domain or in the time domain. So there are two type of domains are there, frequency domain and time domain. And after that, in channel there is noise that has to be incorporated and included in the channel. So after that, when the signal will be received, so there is a masking of a filter that masks the filter and just take out the extra carrier signal and get the main things. You have to get the message signal, right? So there is some residues, that's vt, that has been came from the noise that has been incorporated in the channel side. After that, you will get the data slicer that will slice the data, and there is a simple clock, so there will be a recovered clock, so you can get the recovered symbols right there. So how did you get in the signals in the modulator section? The opposite is in the demodulator section that you can get it. So that is the thing of the PM scheme, the basic PM scheme. So if you go further, so in binary PM, each symbols AK takes only two values, says that A1 and A2, and in a multi-level, that is AMRI system, symbols may take M values, that is the A from A1 to AM. So that has been denoted as the subset, or you can say subscript A, subscript 1, A subscript 2, and A subscript M. And the total period, this was called the signaling period T, that's capital T here. So each transmitted pulse is given by AKHT T minus KT, where T of function T is the time domain pulse shape. So that we can get it from the channel, right? So after that, to generate the PM output signal, we may choose represent the input transmitted filter, that is HTT. It has been just masked or trained or weighted impulse functions, that is delta T is the impulse function. So we just make the impulse function to HT. After goes into the filter output XT is the train of pulses, each with the required shape HTT, that is the required shape. 10 pulses, the trains, as we came from the clock shapes, right? That is going to be the symbol clocks as you can see here. So after the masking, it's called the masking and unmasking techniques. Unmasking is in the receiver side, so you can get the PM, that is one kind of a sampled signal, right? After that, when it goes to the transmit filter, so it has some waveforms right there. There are some waveforms, that means some masking has been incorporated by using the HT. That is the unit impulse, and that is the impulse function. So there is a huge difference between unit impulse and impulse function. Impulse function has some amplitude, but unit impulse just have amplitude of 1. Neither right side or left side will have enough data to make a waveform out of it. Okay, so that's the thing. So if it's a transmit filter, so if you just incorporate the HTT, that kind of impulse signal, that's kind of impulse signal, so you can find it. So that is positive, you will get this. That's negative, you will get that. Negative, you will get that. Positive, you will get that. Negative, you will get that. Just masking the filter section. The filtering of impulse function train is transmit filter. So it is a filtering technique. Okay. So the PM continues. So clearly not a practical technique. So use a practical input pulse shape, then filter to realize the desired output pulse shape. Store a sampled pulse shape in a room, is read-only memory, and read out through the DA converter, digital to analog converter. The transmit signal XT passes through the channel HC omega and the receive filter HR omega. The overall frequency response will be the transmitted, the channel, and the filter impulse responses. You will get the multiply of the three things in the frequency domain. You will get the overall frequency response. So that's the frequency response of the PAM.